Hello, I've been using this cheap FlySky 6-channel transmitter for a few months now, and it's working out really well. I really like it. It's better than I expected. I heard that there is an open source firmware available that you can flash onto this to change a few things. The main thing is that you'll be able to use 10, I think 8 or 10? Yeah, 10 channels instead of 6. So you'll be able to use all of these inputs up the top as your auxiliary channels, as well as just the sticks as normal. So I've always been thinking that I'd give that a try sometime, but I never really had a big reason to. But I just, you may have seen my video from yesterday where I changed something inside the transmitter so that one of these pins now is going to be accepting an external voltage so that we can see the flight battery voltage on the telemetry screen on the transmitter, and we can set an alarm so that the transmitter will make a noise as we're flying to let us know that the flight battery is getting low. One of the catches with that though is that the default firmware doesn't let you set a battery alarm voltage higher than about 9.8 volts, or around about 10 volts, which is not going to be enough for a 4S battery as we are most commonly using to fly with. So now I do have a reason to try flashing this firmware. The other reason was that I thought I might screw it up, and I didn't want to screw it up, but I actually bought another one of these transmitters as a spare, and I might give to my friend actually. So if I screw this one up, I won't be out of any flying time. I'll just be able to fly with the other one. So one of the conditions with doing this mod and getting the 10 channels is that instead of using ppm, which is what I have here, you have to use the IBUs output of the receiver. So I thought I might just quickly go over how you set up using IBUs output from this receiver into CleanFlight, because a couple of people have made comments on my previous videos asking about how to do that. Painless360 actually made a video not too long ago about that, and that's where I got my info from, to be honest. So you might want to have a look at his video too if my explanation is not clear, but it's pretty easy. So I wasn't actually going to do a video on it, but since using IBUs as part of the requirement for getting the 10 channels from the new firmware, I will just look at that quickly now. So to explain what I have sitting on the bench here in front of me at the moment, this is a Flip 32 flight controller, and it is connected by USB to my computer, and it is also connected to a 5-volt power supply over there. And then the 5-volt power comes through here to power the receiver, and then this is the ppm/channel 1 pin at the top there, which is not focusing, but there it is. So that pin there is going into channel 1 on my receiver inputs. So that's the normal way that you use ppm, and on CleanFlight, to set that up in the configuration tab, you select RxPPM as your receiver mode. So that's pretty simple, and I think a lot of people are doing that. This other plug I have in here is just to connect the 5-volt rail to my sense pin for the battery voltage that I changed yesterday, because if I don't do that, we get this. And I thought it'd be kind of annoying to have that going through the whole video, so I'll just plug that in there so that we don't get that, that's all. Okay, so to use IBUs, you need to make a few setting changes. In CleanFlight, you need to go into ports. So one of the slight issues with this is that you need to use receiver pin 4, at least the way I'm going to do it. And I think most people will probably do it this way on a racing mini quad. At least you won't have anything else. Maybe you might have an OSD that you want to use on here, but you won't have a GPS or anything usually. So I think the typical case would be most people would do it the way that I'm about to do it here. So receiver pin 4 is going to be the pin that receives the IBUs signal. So back over in CleanFlight, in the ports page, we need to say that UART2, which is receiver pins 3 and 4, is going to be used as a serial RX. and then we do save and reboot. And then in the configuration page we change from using PPM to using RX serial. And just below that we also need to say which type of RS serial receiver we are using. So it's IBUs at the bottom. Actually, just before I save and reboot, I'll just show you one other thing I wanted to look at is receiver. So, alright, so you can see me moving the sticks there. Now when I let go of the sticks, take a look at the numbers. I'm not touching anything, but the numbers are sort of jittering around just a little bit. And this is because the PPM signal is based on measuring the times of the pulses that are coming through that signal wire. So the voltage will go high and then low and then high and then low. And depending on how many microseconds that was, it's deciding what this number here is going to be. And the timings between the sending side, so that's the receiver, in this case the receiver is sending the signal, right? And the flight controller is receiving it, so it's going this way through the wire. And the clocks are not perfectly matched. So every now and then it'll interpret it as, for example, here we've got 1004, and then every now and then it'll interpret it as 1005. So this is a PPM signal. That's the kind of thing you get with it, and we'll see that this is going to go away when we use IBUs. So just a nice little side effect. Alright, so back in my configuration tab, what was I doing? Alright, so RX serial up there, and then IBUs, and then save and reboot. Now if I go to the receiver tab and move the sticks, we'll see I'm not getting anything. And that's because I have to change my plugs now. So now, instead of using the PPM/channel 1 plug, we need to use this IBUs servo. And servo is a bit of a strange name for this in this case, because we don't have any servos, but it basically just means like the output commands given to the flight controller. So I'm going to remove the PPM plug and I'm going to put it in here, and then yes, so the ground is on that side. Pretty sure that's right. We'll soon find out. And as I mentioned before, instead of using receiver pin 1 on the flight controller, we need to use receiver pin 4, which is that one. And unless I've forgotten something, that is about all we need to do. Let me just see what's happening here. Yeah, that's it. So now I'm moving the sticks, obviously, and we are receiving the signal from the IBUs instead of from PPM. And notice that when I let go of the sticks, there's no jitter, because this is a different type of signal. It's not measuring the number of, or the timing in milliseconds between pulses. It's a little bit more sophisticated. I don't think we really need to go into the details just here. Alright, so now that we've figured out how to do that, we're going to have it that way to use the firmware flashing that we're about to do. So this apparently is where you got to go to get this stuff. Ben Bojangles on GitHub, and he is working on this, and he says progress is being made, and this is a pretty neat project. One of the really nice things about this, apart from getting 10 channels, is that you can make this bloody idle alarm shut up. So this transmitter, if you leave it for, I think it's just 60 seconds, if you don't touch anything, it starts making diddle-oo kind of noise to let you know that you've left it on, and I think it's every 10 seconds after that. It's just so bloody annoying. So that is going to be changed to 10 minutes, which is really nice. So the files that you need to do that are in here, and unfortunately this can only be done on Windows, I found, so I'm going to have to do it on Windows. And look in here, and we can see some more details there about exactly what this update is going to do for us. So we get 10 channels. Yeah, so 4 extra aux channels. There was something about the idle timer as well in here. Maybe that was in the last release. I'm not sure. See, there it goes. And anyway, what I wanted to do was this one here. I wanted to set the receiver alarm to be up to a 4S LiPo, which is exactly what I think he's intending to do as well by the looks of it. So if I just go back to the main page of this, we scroll down a bit here, we'll see some info and a screenshot of the updater program that you use to do this. Now I am not going to show you me doing this, unfortunately, because I tried it using Wine on Linux and it didn't work. And then I tried it using my 32-bit Windows laptop running Windows 7, and it also did not work. So I'm guessing that this program has been compiled for 64-bit Windows only. And the only machine I have available to run that is the machine that I'm running my Linux on right now and recording this video. So I'm going to have to shut this down and switch over a hard drive inside my desktop computer to use Windows instead of Linux. And I can't actually record anything for YouTube while I'm doing that. But what I'm going to do is, if we scroll down here a little bit, I'm just going to go through this step-by-step instructions. So there is a firmware update menu that you can get to by accessing the hidden menu on the transmitter, which is done by holding these both down to both into the bottom left and turning this on. And we get a different menu this time, so it says factory menu. I haven't really paid much attention to this, but down here we can check what the firmware version is. So that's just the default one from the factory, I guess. And then in here we can go there, and from this point on I'll just be following the instructions as written on this page below, and they are so you need a FTDI adapter to do this, and you're going to be connecting up to the balance port, not balance port, the trainer port in here, so there'll be RX and TX, and then the outside ring is ground. I think that's all you need, just those 3 pins, is it? Yeah, it looks like just the 3 pins. So he's just got these 3 lines coming in from his FTDI adapter. I happen to have exactly the same FTDI adapter too, so it's always kind of reassuring, isn't it, when you have exactly the same thing as somebody else when they're you know, telling you how to do something that might ruin your transmitter. But anyway, just here in very, very small text you can see the instructions. So I'm just going to follow these steps now. Like I say, I won't be able to record this and show you, but I'll take a little break here and do this, and hopefully it works, and we'll come back afterwards and see it in action. Slight change of plans. I discovered that you can actually do this on Linux through Wine, and the reason for why it didn't work before, this is a little embarrassing actually, but when you're looking at this page here where there's a link to download the exe file, don't just right click this link and save it, because if you click on this you'll find that it takes you to another page, so you'll just save this page, and then if you're a dummy like me you'll try and run this as a program. Hey, stop laughing. It's been a long time since I did that before. So what you need to do then is click on this, and then that will let you download it there. Alright, so I'm back on Linux and I have this program running. Looks a little bit different to the way it looks on Windows. As we can see, where is it? Right. Anyway, it looks a bit different, but it works the same. And I have COM5 selected, which is my port, and that is this. So this is COM5 is my FTDI adapter there, and I've connected this up to the back of the, it's a little bit precariously poked in. The RX and TX are fine, but the ground pin is sort of jammed in just on the side there. I tried flashing just now and it worked, so it's not a huge problem, but I don't want to sort of bump it too much while it's in the middle of doing it. So to get this to work, it's actually very, very easy. We turn it off and then hold the sticks to the left, both sticks to the left, and turn it on. And that will bring us to the factory menu. And then we go down to firmware update. We say OK. This will enter firmware update mode, blah blah. Press OK to proceed, and then there's another one, confirmation here, so we just use the up and down keys to move the arrow to yes, and then we push OK. The backlight goes off, and it might be a bit hard to see there, but it says update mode on. And then once you're in that mode, I'm going to try not to bump it. Then you can click open port, and you should see in this area below here, you should see a version number appear. So this appeared just here. Looks like we are good to go. FlySky i6 1.10. And then you just click program and wait for a bit, and when it's done that, it should restart the transmitter like so. And then I guess we do close port. It probably doesn't matter at this point because it's not in update mode anymore. It's just gone into the regular menu. And you'll probably notice there that now all of your model memories have been erased. I actually had quite a few, but that's alright, I suppose, because as we look through the menus, we'll see we now have 10 channels available. So let's have a little look here. Right, so if we go into display, we'll now see we have 10 rows of values. Oops, sorry. And they've been reset to their defaults, so the defaults are to use these variable dials here as channels 5 and 6, which is what's going on there. So let's see if we can change these to use all of our switches all at once. So then in aux channels setup, now we have 6 aux channels to choose from. Look at that. So let's say, oops, channel 5 will be, oh, and we have a mix of switches too. I'm just going to leave that for now, but that's a nice option to have. Alright, first one is VRA, second one is VRB, let's leave those, and this will be 3, 4, 5, C, D. Excellent. Save that and go back to our display. There we go. So now we have 4 switches and 2 dials, as well as our 4 normal channels for the sticks. Ah, this is great. And the other thing that we wanted to look at was the receiver voltage. That is over here, isn't it? This is an RX setup. And now in RX battery, we have a completely different menu. And we can choose here NIM or LiPo, and external LiPo as well. Still not sure how you get that external LiPo to come through from somewhere, but anyway, so internal LiPo sells for, and it's got some defaults there. I would probably want to set my defaults to what is it? Oh, look at this, we get very fine control too. This has been changed as well, hasn't it? Something like that would tell me that I really got to stop. And I want the alarm to go off at about 3.5. So I'll try this in a minute and see how it goes. Something like that is what I'm used to. What are these numbers over here? It's a quarter of that, isn't it? Not sure if this is doing what I think it's doing, but we'll try it in a minute and see. And yeah, I guess that's the main things that I wanted to check. And I'll also be very happy to find out if it's going to stop this 60-second beeping thing, which has been annoying me so much. Yeah, that's great. Let's actually confirm though that we can get these 10 channels to come through on our IBUs at the other end through CleanFlight. So let me just plug this back in and power up the receiver. Oh, it's not bound, is it? I've got to bind it. Everything has to be done all over again. Okay, so let's bind this receiver to the transmitter. Is that it? I think that's it. So bind button, turn this on, RX binding, and then I'll just power cycle the receiver. RX bind OK. Internal voltage is 0. There's no alarm going. I would have thought the alarm would be going at this point. Interesting. So let's put our 5 volts back on and see if we get 5 volts being read. Okay, so it's reading 5 volts when it's 5 volts at least. I'm still not quite sure why the alarm is not going off at this point though. Let me just have a quick look in that menu. High 5. Yeah, not sure why the alarm is not going off here. Anyway, let's look on CleanFlight to see about these IBUs values. So connect, and we want receiver. What do we got here? Yep, look at this. Sweet. So we got this will be channel 1, channel 2, channel 3, channel 4, then we've got channel 5, 6, 7, 8, 9, and 10. Beautiful. Exactly what we wanted. I like it. Alright, I think that pretty much covers everything. I'm a bit puzzled as to why the alarm wasn't going off when we set it to be 3.5 volts per cell, presuming that's going to be 13.5 overall. Yes. No, 14 is it? Yeah, 14. No? What's 312s? Yeah, 14. So I'm not sure what that's all about. One other thing I thought I might look at, which is another benefit of IBUs, which if you're a real pro pilot you might appreciate, is that IBUs can do updates quicker than the original PPM. And to check how that works, we are going to need one of these, which I got a little while ago on Banggood, believe it or not. I actually trusted them with a $320 purchase of a rather delicate item to be shipped all the way from China, and fortunately it worked out. Nothing was broken, it works fine. It arrived in about a week, well, not quite a week, but wasn't slow or anything. I was quite impressed. So what we're going to do here is we are going to, where's those little pieces of wire? I'm just going to look at the pulses that we get from ppm, and then the pulses or the signal that we get from the IBUs line. So I'll just power it from some other pin at the moment. Oops, that way. Yep. And you can come down here a bit so you can see. So black is going to go on to ground there, and white is going to go on to the ppm signal pin. And I've just remembered that we have to actually tell the receiver that it's supposed to be doing ppm as well. Oops. Okay, so it should be outputting ppm now, I think. So we want to connect our oscilloscope ground to there, and oscilloscope positive to there, and I'll just hit the auto button. This oscilloscope, oops, you probably can't quite see the model number, that's the one there. It's yeah, 2 channels, 100 megahertz, 1 gigasample second. I don't know a whole lot about oscilloscopes at the moment, but bloody York Brocking, it's his fault that I bought this, because he shows using oscilloscopes for various things in his videos, and I thought, wow, that's really useful. Anyway, so we can see some pulses coming through. This is the ppm pulse, and if we move it over like that a bit, we can see that there are what you call frames of data coming through, and each frame contains, in this case, if I just sort of stop it there, we can see that there are 6 pulses, because as I mentioned at the beginning of this video, we don't get the 10 channels upgrade from using ppm. That's why we need IBUs to do that. So ppm is still only going to give you the first 6 channels, and the way that works is by measuring, of course, the time between rises of each of these pulses. So that's why you get a jitter. It's just measuring a time between them, and these times are not always accurate. But what I wanted to look at here was not so much the times between the pulses as the times between the frames. So each set of these pulses here is one update that the receiver is telling the flight controller what you're doing with your stick movements. And you look at the scale at the bottom. This is 1 volt per, oh sorry, what do we want? 10 milliseconds is the time per square on this grid. So if we look at, where's the pointer? So if we look at the beginning of this frame here, and then from there to the beginning of the next frame, it's two squares on the grid, so that's 20 milliseconds. In other words, you can get about 50 updates per second, just because of the time it takes between them. You have to leave a space between them, otherwise you can't tell which set of pulses is which frame. So just keep that in mind. We're going to look at the IBUs pulse next, but the point is that ppm is going to give you 50 updates per second maximum of your controls going into the flight controller. Now if I connect the signal line up to the signal line of the IBUs output and run that again, we can see sort of a similar kind of thing. We have a bunch of pulses there, but they're a lot more, they're a lot smaller and shorter, because this is now not it's not measuring the time between them. It's a digital sequence of serial information. But the point again is that we want to check the time between consecutive sets of pulses. So one frame here, one frame there. The time now, if we look at the times, milliseconds per division is only 2 now. So that means that the time between each frame is going to be 2, 4, 6, well, let's say 8. Let's be generous and say, let's be conservative and say that it's 8. It's going to take 8. So that's about 125, is it? 1000 divided by 8 is 125. Let's say 120. So instead of the 50 updates per second that you were getting from your ppm, or in other words, the 20 milliseconds between updates, now you can do 120 updates per second, or 8 milliseconds between refresh updates. So theoretically, if you're a real superstar pilot, that should let you, when you're moving your sticks, it should let your control inputs get from you through the receiver and into the flight controller quicker, about twice as fast as using ppm. Plus we've got 10 channels as well, so it's a win all around, isn't it? So big thank you to Ben Bojangles and all the people that were working on this. Where are we? They were mentioned somewhere. Not this page. They are mentioned multiple times throughout this project though. Where is it? Here we go. So there's the main contributors there. So big thanks to these guys. I don't know how the hell they did this, but they managed to do it. So anyway, these videos tend to get kind of long, don't they? But hopefully something in this video will help somebody. Maybe. Anyway, thanks for watching. Hello, me again. I figured out what was going on with the battery alarm. It seems like it just has an exception for 0 volts, because if we bring a non-zero voltage within the range of the alarm settings, the alarm will go off. So if you remember, my alarm settings before were the medium alarm was to go off at 3.5 volts, and we're just a little bit above that. So if I turn the voltage down here to below 3.5, then we do get that, the first alarm, or the slow alarm, or the medium alarm, or whatever. And then if we go below 3.3, we get the serious one. But what's interesting is when I turn this off, hopefully you can see this over here, when I turn this off so that it's 0, it doesn't do anything, which is actually quite nice. It means that I don't have to make sure that there's some voltage on there when I'm, just sort of doing some testing and plugging things in and having things in a sort of a partially assembled state like I have quite often. It's not going to be buzzing at me all the time. So this is quite a nice exception. If it's done intentionally, which it seems like it might be, then that is a good idea. So it's only when it's a non-zero that those alarms go off. If I turn it back up. So then on this menu that we saw before, I guess, so this is the overall voltage that you'll be setting, and I guess these ones over here, it's just that divided by 4, so it's just sort of to let you know that what number you're setting per cell, if this is the overall voltage. Just a convenience to divide that number by 4, so that you don't have to do it in your head. I suppose that's what that's for. Anyway, so that's really great. Only thing that's a slight annoyance is that now that we can set these numbers in such fine detail, because they're hundredths of a volt now, the only problem with that is It's going to take a long time to set them all up to, well, what would this one be, 16.8? It's going to take a long time to get there. I kind of feel like this could be done in, say, 5/100ths of a volt would be good enough. And then it would at least be 5 times faster to set on this menu. But anyway, that's really great. Everything is working just fine. Okay then, see ya.